The question is for the utility function u, that is utility is a function of two goods x and y which is equal to x times y, and the given budget constraint is total income is denoted by m, which is spent on two goods x and y, given the price of good x as px and price of good y as py. Okay, we have to find out the optimal bundle of consumption of good x and y. Options are being given, we need to find out the correct option. Okay, so since the consumer wants to find the optimal bundle, that means we want to maximize the given utility function, you know, that is equal to xy subject to the budget constraint, that is price of x times units of good x plus price of y times units of good y should be equal to the total income of the consumer. Okay, now optimal condition requires that marginal rate of substitution between x and y should be equal to the ratio of the prices of good x and good y. MRS is simply the marginal utility of good x upon marginal utility of good y. It should be equal to price of x upon price of good y. Okay. In turn, marginal utility of x is simply the derivative of utility function with respect to x, and marginal utility of y is simply the partial derivative of utility function with respect to good y should be equal to the ratio of the prices, that's price of x upon price of y. So if I take the partial derivative of this function with respect to x, I will get derivative of x is 1, so I will be left with y. So du upon dx will come out to be y divided by du upon dy. That means partially differentiating this utility function with respect to y, so I will get x, because derivative of y is 1, so I am left with x should be equal to price of x upon price of y. Okay, what exactly is meant by this on the graph? Let's draw a small graph to save the space here. So we have good x and good y here. Okay, we have the budget constraint for the consumer. Okay, given this budget constraint, consumer wants to reach to the highest possible indifference curve. Let us say this is IC1. Similarly, we have IC2. Okay, so with the given set of given budget, consumer wants to reach to the highest possible indifference curve, and optimal bundle will lie at a point where the indifference curve and budget line are tangent to each other. Okay, now or we can say that when the slope of the IC and the slope of the budget line is same and they are tangent to each other, and this point, the tangency condition is, that is MRS should be equal to the ratio of the prices, price of x upon price of y. MRS is simply the slope of indifference curve, and the price ratio is the slope of the budget line. Okay, having said that, let us solve this for y. So we have y is equal to price of x upon price of y times x. Let us substitute this into the budget constraint. So here we put the value of y. So we get price of x times x plus price of y times the value of y is price of x upon price of y times x. Okay, should be equal to m. Now py and py gets cancelled, so px times x plus px times x, it comes out to be twice p x times x should be equal to m, which gives us x, that means demand for good x will be equal to, or optimal bundle of good x will be equal to the total income of the consumer divided by, if I transpose this, it will get divided, so twice px. Okay, this is the value of x. Now what is the value of y? Simply plug x is equal to m upon 2px here to get the value of y. Okay, so let us plug here the value of x, so our y will be equal to price of x upon price of y times the value of x is m upon twice px. Okay, px and px gets cancelled, that gives us y will be equal to m divided by py into 2 is twice py. Okay, so these are the two optimal, rather these are the optimal combinations of good x and y. So x will be equal to m upon 2px, y will be equal to m upon 2py. So we have here, it is not the case. In the second one we have m upon 2px, that means optimal consumption of good x. This denotes optimal consumption of good y, so that means option B should be correct.